Okay, so let us start with the plaster of Paris. Okay, so plaster of Paris. What is so special about the plaster of Paris? Very simple. The plaster of Paris is one compound which becomes hardened as we add water to it. Okay. So what is the formula of the compound and how it is formed? And it is what is the use of this compound? Okay. So again, the same thing. We have to understand preparation, then reactions. So characteristics. What are the characteristics? And uses. These three things that we have to do. We'll be completing this thing. Okay. First is the preparation part, then is the characteristics part, and finally the uses part. Now, what is the method of preparation of this compound? Simply, this compound is prepared from gypsum. So, plaster of Paris, in short, I will write POP. POP. Okay. So, plaster of Paris is formed by heating gypsum. By heating gypsum. Okay. So the formula of gypsum is CaSO4 dot 2H2O, and on heating it is going to form CaSO4 dot 0.5 H2O, or we can say that CaSO4 dot half H2O, or we can say that it is nothing but, or it is CaSO4, and I write 2 here, dot H2O. All are representing the same thing, that is the POP, the plaster of Paris. Clear? It's very easy to understand. Right? So the plaster of Paris is very easy to understand. It is basically what? It is a compound formed on heating calcium sulfate dot 2H2, which we normally know, it is known as gypsum. And at what temperature? The temperature is 373 Kelvin, which is 100 degrees centigrade. So it is 100 degrees centigrade. So on heating this substance, we will get POP. So just writing it again so that it should not be confused. It is 2H2. Is it okay? This is the case. So balancing it, we will get. So 1.5 or 3 by 2 H2 is evolved. Okay, 1.5 H2O is evolved, or 1 by 2 H2 is evolved. Okay.
But sir, how do you add like 3 by 2 H2O to add make it?
Sorry.
Sir, then how do you add 3 by 2 H2O to make the?
No, we are not going to add it. We are not adding it. What we are doing is we are heating. While heating, the compound that is formed, if the temperature is around 100 degrees centigrade, it is going to form CaSO4 dot 0.5 H2O, and 3 by 2 H2O is released out. The compound is released, not we are releasing. Okay.
Okay.
Okay. So what we have understood till now is that we are heating gypsum, that is CaSO4 dot 2 H2O, and we will get plaster of Paris. But the problem here is the temperature. If the temperature exceeds 100 degrees centigrade, then there is all probability that we will be getting this 0.5 H2O out, and we will get CaSO4 and hydrous CaSO4 instead of CaSO4.5 H2. Okay, so this is something different. So what we have to understand, it is that the temperature should be carefully monitored. It has to be 100 degrees centigrade. It should not exceed 100 degrees centigrade. Otherwise, the 0.5 H2 will also be released and we will get anhydrous calcium sulfate instead of POP. Is it okay? So the temperature must not exceed 100 degrees centigrade. Just write it down. Just write it down. In the preparation of plaster of Paris, the temperature should be carefully controlled. Full stop. If the temperature exceeds 100 degrees centigrade, that is 373 Kelvin, then all the water of crystallization, that is all that is H2O attached with the molecule, will be eliminated and anhydrous calcium sulfate bracket will just write it down. That is also called as dead burnt plaster. Bracket close.
So dead burnt plaster.
Dead burnt plaster will be formed. So if the temperature exceeds 373 Kelvin, so we will get CaSO4 plus all the water, that is 2 water, will be evolved instead of this one. So this is called as anhydrous calcium sulfate, also called as dead burn plaster. Why it is so? This because if we obtain this one and if we add water, then this calcium sulfate, that burnt sulfate, is not going to set, just like a plaster of Paris. So that is important. When we add water, nothing is going to happen with this. It is not going to set like POP. So you can write it down. The dead burnt plaster does not set. The dead burnt plaster does not set like plaster of Paris on adding water.
So can you repeat the last line?
The dead burnt plaster does not set like plaster of Paris on adding water. Okay, correct. Now come to the properties or characteristics of this. First of all, we have already seen that POP is a white powder. It's the first of white powder, no issue. Second, and the most important one, POP has a very remarkable property. of setting setting, setting into a hard mass, on wetting, wetting, wetting with water.
Sir, can you repeat the second point?
POP has a very remarkable property of setting into a hard mass on wetting with water. On wetting with
Sir, POP
water.
has a property has a very remarkable property of setting.
Setting. It sets, no? setting. Setting. It becomes hard. So this phenomenon is called as setting. Okay, property of setting into a hard mass, on wetting with water. Okay. This is due to hydration. This is due to its hydration. You can say its hydration. This is due to its hydration to form crystals of gypsum. Which set to form crystals of gypsum which set to form set to form a hard solid mass. Okay, so what we are getting, if we are getting adding water, now initially you can just make a plow of sort of thing. Okay, so when you are having CSO4 half H2O, when we add some water, then the reverse of the reaction is going to take place. So CSO4.2H2O is going to form. This will first heat it, so it is an exothermic reaction, and ultimately it will form gypsum and is going to set. Okay, so very, very important property that we have understood now. So let us just write it down also. Properties of POP. So the first thing that we have understood is white powder. That's okay. Writing with yellow, but it's white. Second, setting into hard mass. On wetting with water. So when we are adding water, wetting with water, when we are adding water, so it is becoming a hard mass, water. So water, this is because gypsum is formed which sets into hard mass, and the second thing, it becomes hard. So exothermic reaction. Again, the reaction is exothermic in nature. Exothermic in nature. Okay, so this is important to understand. Another thing is,
Sir, so when we add CSO4.2H2O plus H2O, what do we get?
okay, so reaction you're talking about.
Yes,
Reaction is very simple. CSO4 is the reverse of reaction. No? Dot 1/2H2O. So when we are adding water, it forms CSO4 dot 2H2O. That is the gypsum. So this is the gypsum which is going to set. So this is what? This is gypsum. So again, it's the reverse reaction. So what is going to react? The reaction is 3/2 water. Okay, plus heat is evolved. It will become hot, heated form. Okay, heat is evolved.
Yes, sir.
Okay, next point. Next is on setting, slight expansion in volume. So expansion in volume. So what are the characteristics that we will associate when a POP sets? First, gypsum is formed. So this is going to form hard mass, number one. Second, it is exothermic. So we will get heat. Third, slight expansion in volume. So its volume is going to increase. Its volume is going to increase. Okay. So that is why it can be used for casting. That is why used for casting. You can see POP statues, isn't it? So statues. So many things are made up of POPs. Okay. Clear? Statues are there, toys are there. You can find so many things made up of POP.
Sir, is
Yeah.
that casting like before statues?
Sorry.
Sir, is it casting or costing before statues?
Casting, statues, toys, etc. We will see some big, I think Saraswati, goddess Saraswati idols and various things have been casted and it has been so on the streets.
That is Plaster of Paris.
So one obvious question that is going to come here is why POP, that is plaster of Paris, should be stored in moisture-proof containers, isn't it? Simple the question. Just write it down. Important question for boards. Why plaster of Paris should be stored in moisture-proof containers? Why plaster of Paris (POP) should be stored in moisture-proof containers? Moisture-proof containers. So it's very easy. So plaster of Paris should be stored in a moisture-proof containers because if moisture is present, it is going to set, which is irreversible in nature. The process is irreversible, and now the POP will be waste. It will be of no use, doesn't it? So we want a moisture-proof container. Done, beta? Any doubt? So write uses of POP. So in hospitals, you can say POP is used in hospitals for setting fractured bones, for setting fractured bones in the right position, to ensure correct healing. Okay, next point. In making toys, decorative materials, etc. In making toys, decorative materials, etc. Next point. Used as a fireproofing material. Used as a fireproofing material. Okay, next point. Used in chemistry laboratories. Used in chemistry laboratories for sealing air gaps for sealing air gaps in apparatus where airtight arrangement is required. Airtight arrangement is required. Where airtight arrangement is required. Okay. Then you can use as false sealing. You can use POP as a false sealing, isn't it? False sealing for making surfaces, etc. False sealing for making surfaces, etc. Okay.
Sir, how is false ceiling?
You must have seen false sealing, no? You on the walls they attach some white paint sort of thing. There are graphite board, there are POPs available which can be used as a false sealing.
Yes, sir. Like I have seen those, but like, why exactly do they use it in like false
Why?
ceiling? Yeah.
Using why?
Why? Yes.
Okay, so the basic reason is for decoration. So we can, since it is a very soft material, can be casted anyway. So we can make very good artistic structures out of it, and we can paste it over it. Okay, so this is not possible when a roof is being made in a slurry of this cement. It is not possible. So once your roof is ready, so your lighting pipes are there, so you can have some piping arrangement. But suppose you want to have decoration, suppose you want to have something very new light should be fitted. Okay, decoration, some very beautiful designs, that is not possible. So we will make a false ceiling, we will make something, a board out of it, maybe a graphite board with false POP boards, whatever, and we will try to fix it. So once it is fixed, now it is very shining in nature, so it will be glowing like anything. Now it can be used for decoration also. It can be used before painting. If something, there is a gap is there, so you can fill it and you can paint it over it. So all these are important applications of this. Okay,
Yes, sir. Understood.
any doubt?
No, sir. Thank you, sir.